Hi and welcome. This time around we have a couple of quick projects. First one is to replicate this thumb screw, the pressure plate mount on the back of it. So I want it to fit on here. This is just a standard metric M12 bolt. This one's too long for my uses. It's for a camera mount and it's going to be a sort of a fixed location, so I don't care if it doesn't have a thumb screw when I'm done. I just want the pressure plate because it's actually going to mount on my service plate so I can take shots there more conveniently. So we just need to take this guy down and match these specifications. Second project is a customer project. If you're wondering how I'm holding this, I have it in a 5C hex collet and it's in there pretty tight. I don't think it's particularly square, unfortunately. Seems like a fair amount of run out. I've got a 5C collet holder rather than collet puller because I wanted this pretty darn tight. And it's a metric bolt, which happened to fit the 9/16 hex reasonably well. It had to close a little more than just the tiny bit they normally close, but it didn't seem like that was a problem. But we do have an issue with it being out of center. So I don't know, maybe I can tap it in. I'm not quite sure. Oh, okay. 25 thousandths. That's a lot. I got this guy pretty tight in here. Oh, that's a little better already. And what I don't want to do is bend this poor thing. I guess we're going to have to live with like the 10 or 15 thousandths. I don't think I'm getting better than that. There's no guarantee this was particularly good to begin with. It's just a bolt I had in my drawer. All right, well, let's see how it turns. I'm going to have to be very gentle with it. Because that is not a very good way to hold the bolt. So I'm shooting for a diameter of 0.314 on the outside here. Holy cow. Okay, that other one was made to size because we're already pretty close. Yeah, that's actually there, so this is not going to be a great fit, unfortunately. All right, well, let's see if we can get, we might have to make something from scratch. All right, now we just need to make the groove. This is quick and dirty, so I'll admit. That's pretty much it. That worked out okay. I'm not happy with the finish on the end there. And I'm gonna see if I can clean up the threads at the very end also, so they'll start more easily. There's a lead in for the threads to start. I think we're done. I find using the 5C collet chuck really convenient if I'm doing a one-off. If you have to do multiple, setting up the collet puller is a great way to go. But for one-offs, it's really inconvenient. Another solution would be use my Jacobs collapsible chucks. I find those give a little slop to the part. They don't hold very tightly. So this is a good way to go in general. And there's the 5C hex. Looking at the final piece. It's a perfect fit. Just a tiny bit of slot, tighten that set screw and it's not coming off. And then I can tighten the stand. I'll show you the stand next. Here's the camera arm that it goes to. And here's the piece down here. You can see why they made it much bigger originally, so that you could tighten up to something very thin here. but I'm going to actually mount this on the ledge of my surface plate here, so I don't need that. If you're wondering why I didn't leave the long screw on to tighten, it's because it wouldn't fit. It would run into this, the thumb screw. So I'm leaving the shortened one on. It'll work better. Next up is a really simple project. A customer brought me from one of my Craigslist ads. He responded and needed some machining done, and he wanted some of these bushings made. This is a brand new bushing from the manufacturer. It's the last one they had. They're not making any more. It's for a set of ski bindings for a snowboard, and it needs to be a press fit in this aluminum. This is very thin aluminum. I'm surprised that his entire body weight this survives, although I think it's probably supported on this whole rail down here, but this is very thin. So this is press fit, and we need to make 8 of these for him. They're pretty tiny. Some material was provided for me. Some 1/2-inch bearing bronze that he bought at local industrial metal place, industrial metal supply where I go. Interestingly enough, the old ones get sloppy, although this one still stays press fit. This thing is 5 thousandths in diameter smaller than the one that he got from the manufacturer. I don't think you could make this one fit very easily. 5 thousandths is a pretty huge interference fit, and you'd have to deform the aluminum a lot or scoop some out. So I'm going with the old ones because the old one's still a press fit and it's 5 thousandths smaller. So yeah, we're not gonna go with the brand new factory original. We're gonna go with the older one. I used the other dimensions on this one, but not the critical one. The other ones aren't so critical. And the other reason I'm showing this, because it's a pretty simple project, is I've tried to figure out a way to sort of assembly line this, and I'm hoping to work. So to make this part, we've got an ER32 hex holder here, and the reason is this one I can undo from the front. I don't have a 5C cullet that fits the stock. This is 1/2-inch stock, but because it's bearing bronze and so expensive, it's almost 40 thousandths oversized, and I didn't have a 5C cullet to fit. I just have major dimension 5C cullets. I know they go all the way down to 64ths, but I didn't have one. So either I was going to have to make an emergency cullet work or go this route, and we're going to try this route. So I'm going to take some notes as I go. So the first thing I'm going to do is I'm going to get my Z0 here. So I'm going to try and use a cutter that I can use through the whole thing and cut out the entire part. I don't know if this one is adequate or not. This is kind of pushing for this, but I need a Z0 so we'll see if we can pull it off. So if I call that my Z0 and I lock my slides, set my DRO 0, and we face this guy, that will set a 0. And I guess before I start removing material, I probably should drill. The center is a very sloppy 1/4 inch. So I'm not sure why they went with a sloppy 1/4 inch, but the manufacturer chose to. So maybe they've got a reason for it. Maybe they needed a little slop in these bushings. I don't know. Just to keep things concentric, I am going to use a stubby drill bit, so we'll be back and re-drilling this several times before this is over. I need to make a total of 8 parts. I don't know if I mentioned that earlier. So I'll just go as deep as I can, which will probably buy me, I don't know, 3 or 4 parts maybe if I'm lucky. Next up, I need to take the outside diameter down to 0.5. So I'm going to set an X0 here, and we're going to go in 15 thousandths. And we'll call this my 0 point. So I've set an X0, but we're not at the final dimension yet. Whenever I get to the final dimension, I'll set my X0. Let's see how close this is. So we're trying to get about 0.5. The other parts were 0.501. Oh, we've got a fair amount to come off still. 0.526. Okay. Once I get my 0 set for this value, I can just come right back to it again and again. So I'm just trying to find where I dial to. So I'm just going to dial in the remaining 11. And we're going to let it ride. This is my new 0. What we're looking at right now is the outside diameter of the large portion. Okay, just double check real quick. If we're within a couple thousandths, it'll be more than good enough. I'm 4/10 over. I don't know if that'll do. The actual parts themselves were 0.501, or 503 actually. So I think they just left stock as factory original. Okay, so the next part, now everything matters at this point. So we've got 125 thousandths we're going in, and we need to get the diameter to 0.355. Like I said, we're not going to go for 0.359, which is what the actual parts are. So from here, we've got quite a bit to come off. Let's see if I can take 40 thousandths off. And we're only going in 0.125. Okay. There's a fair amount of stick out. 0.460. We're trying to go to 0.355, so I've got 105 to come off. So let's see if I can do another 55. We'll do this in pieces. So the beauty of the facing cut, it gives me a very accurate Z0 with the DRO. So I've got 50 thousandths left to go. Once I get all the way in, this should be the final dimension. Come out and give a nice flat face. I think we're good. Now the beauty of using the same tool the whole time, there we go, 0.355. So the beauty of using the same tool the whole time is that my reference points don't change at all. So since this also cut the face, which it's not an ideal cutter for doing the facing job, but it does give me the ability to set my 0 point so that this depth is accurate, so I can use all these values and get right on the size. And I blew it this time around because I set my 0 as this final depth here, but that means this outer diameter, I should have had an offset instead. So now when I pull this rod out, I'm gonna have to do it all over again. That was stupid, my bad. All right, so I've got my parting tool off here, and I set my 0 by touching this end. The parting tool is 0.0775 thousandths thick, because it's metric, I'm sure. So then I come over 0.0775, which gives me the right side 0, matched with this face. Come in the full depth, which is 0.175, and we're going to part this off, and then we can make another one. Even with my narrowest parting tool, we're still losing a lot of material here. There we go. Now this guy can take a pair of diagonal cutters and remove most of that burr and then polish the rest. I've deburred this part on the inside and out, and it's a perfect fit. So 7 more. Third part. Set my Z0. Very good. Deburr that side. Let's see, let's try and leave 20 thousandths of material. Let's see if we can actually pull this off. Yeah, it worked great. Okay, last 20 thousandths. Might even be able to do this in one shot, get these parts down to like just a minute or two per part. Wouldn't that be neat? By the way, that's what makes this fun. Assembly line work in itself is not overly exciting. But trying to trying to figure out the process is very interesting to me. My new Z0, 77.5, 75. Get part way there. Remove the burr. And that's it. On to the next one. All right, so we're done here. Here's the original two. Here's the ones I made. The customer said they wanted 4 or 8, depending on how much it was going to cost him. He was prepared to pay $50 a bushing, which is quite a bit. The setup took a little bit, but once I got the setup, these things were down to a few minutes a piece. Mostly deburring, actually. The actual cutting was very quick. Faced it off, pulled back, cut the entire thickness of this inner lip here, and parted it off, all in just 2 steps, very quick. These bushings, this bindings are held to the snowboard by this piece right here, and these fit fairly loosely. Oh, look at that. Wait a minute. What's going on there? Uh-oh. Houston, we have a problem. Makes me wonder if my 1/4 inch drill bit was not a 1/4 inch. Holy cow, I'm glad I tested that. Yikes. Somehow my 1/4 inch drill bit that's labeled 1/4 inch, and it's a high quality one, I thought. It's not a 1/4, it's something slightly smaller because the originals fit on here perfectly. These guys are all tight, and I thought maybe it's a burr, but it doesn't seem to be. So now I'm gonna have to pop these back in the lathe and ream them all out to 1/4, I guess. Wow, I don't know how that happened. Fixing these guys is easy as putting them in another collet. This is a ER32 collet as well. Put the nose in like this, and then just run a .251 reamer through. This is a carbide reamer, and it's barely taken off any, so I think it's just burrs or something. I don't know, it's pretty weird. But the original ones are much oversized, so they're like 255 thousandths. I didn't make this as far oversized. I didn't think there was any need to. At least we're good now. Here's the factory original part. Totally sloppy. It's like 5 thousandths oversized. Here's a brand new factory part. Also 5 thousandths oversized. Although this one will never fit in here in this hole without completely stretching it out, because this is 4 thousandths in diameter more than the parts that are in there. So as an epilogue, I was concerned about the fact that mine were so much snugger on the pin than the manufacturers. So I went and ran them all with a 253 thousandths reamer, and now they're all sloppy on here. Not as sloppy as the 255, but I don't think that's necessary. They go on very easily. I know when things get cold, they shrink for the most part. Hopefully these won't shrink more than the pin does. Maybe that's what they were concerned about, but I've given them a fair amount of slop now, so it should be able to come out. All right, thanks for watching. Hope you find it useful. Hope to see you next time.